Hi everybody. Everybody having a good show so far? My name is Dan Pisarski. I'm the VP of Engineering for LiveU. We make a bonded IP connection, portable, rugged encoder. So we're very involved on the first mile, and my involvement with latency is definitely in the first mile as well. We developed our own protocol to use with the bonded encoder. So we're very hyper aware of the relationship between latency and resiliency, which is something I hope we'll cover a little bit today. But I'm definitely a little bit less of an expert once it gets to the middle mile and the delivery side. I geek out on the subject just like everybody here, but it's not what we focus on as a company. So I'm glad we have the panel here to talk about that side as well. So we'll go around and we'll do introductions. If you want to make any statements about your service and NN latency or any focus on latency that you have, it's a good time, and then we'll dive into some questions on the impact of latency on streaming.
Okay. I'm Scott Grizzle. I'm a senior sales engineer for IBM Cloud Video, formerly Ustream, working with Watch, the Watch and AI stuff around making video enrichment. I'm not going to say we're ultra low latency company, because we're not. We're one-to-many, massive viewership and authentication. So we have experience with low latency, and I can tell the difference between long latency, standard, and then I can also cover low latency from my previous careers.
And I'm Sean Keene. I'm the Vice President of Product Marketing at INXPO. And at INXPO we do live streaming and primarily webcasts and webinars. So we're involved with the first mile as well as the delivery side of things. And today I think some of the topics that I'll be covering are the unique challenges when it comes to the webcasting space with the live stream, the interactivity, the text-based interactivity that goes on, and the latency considerations that come into play there, as well as the fact that there are different latency considerations for the presenters versus the viewers, because we want to have a live conversation with multiple video presenters. Obviously, we need to keep that latency ultra low. So we come up with some interesting solutions for that will color the conversation we have here today.
Great, so let's jump in. As usual, let's start with a little definition of terms, I think. What would you say the difference between latency and delay is? And you touched on this a little bit. In what use cases does latency matter, does delay matter, and does the audience notice it, do the presenters notice it? Let's break it down a little bit so the audience understands latency better, what we're talking about up here.
Sure. So, and latency and delay, it's a tough thing because I feel like when I'm talking to our clients, both are bad words.
Yeah.
Both are very negative. And part of what I have to try to do is change that discussion a little bit. The way that I look at it is, when we're talking about latency, that's the glass to glass. That's between what happens in real life and what you see happening on the screen. And what I try to explain to our clients is some amount of latency is natural. There's no getting around it. That's the nature of the beast when you're talking about streaming to large audiences. Delay is a different matter. Delay is the thing that I say, hey, you guys think it's a bad word? We do too. And that's when, for us, things fall out of sync. Because, again, when we're talking about webcasting, it's the live streaming. A lot of times slides go alongside that. There's the chat, the Q&A, and all of those pieces. And I think part of the challenge from a technology standpoint is keeping all of those elements in sync so that if I'm talking to my slides, I'm not a minute ahead or a minute behind my slides, or even a few seconds. If I say, hey, and now, click, we're going to look at this, that needs to happen instantly. If that doesn't happen, if those fall out of sync, in my world, that's a delay. Or if a presenter is doing screen sharing to do a demo, which stuff we do all the time on the technology side, if that falls even a couple seconds out of sync, that in my world becomes the delay, and that's where, hey, if those are in sync with one another, it's, to the end viewer, they might not know if it's 30 seconds behind real time. But if those two elements are 3 seconds, if there's a 3-second delay between what I'm saying and what you're seeing on screen, then that's where the delay comes into play, and that's where the audience suddenly goes, hey, there's something wrong here. And from what I've seen, they can start paying more attention to that delay than they do to the content.
Yeah. I'd like to throw one more term in there also.
Sure.
Perceived latency versus actual latency, and then with delay. Perceived latency is, we're in the room. So if I have the monitor up here of the stream back there, you will perceive latency. Now, if you're at home watching, you will not perceive it. So there actually is a real actual latency and delay. And for me, delay is actually transit time. I mean, from ingest to transcoding to repackaging, all is part of the package. Then when you have to distribute out, I mean, multiple CDNs and how long it takes from point A to get to point B is in transit time. And that's where it really I count delay. But if you look at HLS, HLS has default 9 seconds of delay built into it because of the packaging. So if you look at that, and then you ultra low latency, RTSP, and other codecs out there, you can get sub-second. It all depends on what the codec's built. Then you add the transit time in, and that's where it gets kind of tricky.
So you just touched on kind of my next question, which is, HLS, you've got a built-in deep delay. There's other delay options out there. Different use cases, demand certain different delays. What's a reasonable expectation of delay on the web? And is it better or worse today than actual live TV?
That's a good question. So I would say the average delay in most cases is 15 to 30 seconds. You see that, it's pretty industry spec. Once you start getting 30 seconds to a minute and so on, there's network issues and overall delay. Your average TV, think about it. If you had you automatically have 10 seconds in TV for the F-bomb button.
Dump delay.
The dump button. But also you have to look at satellite. You all have seen, now do you, Jim? Oh yeah, it's our fine. So there's always delay in TV than the response, and that's where the internet's great around because you can actually do peer-to-peer. You actually have you can get millisecond delivery in talk-to-talk. That's why a lot of companies are using LiveU. A lot of people are using the IP backend to reduce that latency versus satellite. We had to go up, down, and everything else, and decode. Versus you can cellular, you're already in a format you need, you can process and use. So I think that's really the interesting thing is internet is replacing a lot of TV stuff. I mean, who's familiar with ASI? Oh wow, I'm not surprised. But how many are using IP now versus ASI? Yeah, it's going that route. You can mux the videos together, you can bundle them. Everything you want to do with ASI, you can basically do with IP, basically.
Sean?
I think that when we talk about the different industry specs, the HLS, the same boat as you, where it's 15 to 30 seconds across the board for HLS. I think that typically where I get called out is that when somebody finds the 15 to 30 seconds, it sounds like a lot.
Yeah.
And it can be behind live TV at some point in time, but somebody's perception of that. But at the same time, then it becomes the conversation of this being the industry standard and what the what it being kind of out of our hands and just how the HLS delivery works and having to get into the discussion because a challenging part for us is we do a blend of HLS and MPEG-dash delivery. And with MPEG-dash, our delay is our latency, or delay, and I realize we use those a little bit differently, much lower. We're talking 6, 8 seconds. And so one issue that I run into is if I'm doing a product demo to a group of people and there's 4 people in the room who are on Chrome, and one who's on Internet Explorer, one who's on their iPhone, they're going, well, this is all out of sync, there's a problem. And I'm going, well, no, it's not a problem. That is certainly to be expected. And then that unpacks the entire latency discussion and the differences in technologies. It's really great when everybody's coming to the table with the same technology, the same browsers, the same tools, and I go, yeah, you're all seeing the same thing across the board. And they can look over and go, oh yeah, I see the same. So I think that for me, it's, we're behind live TV. It's a discussion, quite honestly, with my customers. I don't want to necessarily do the comparison to live TV because it's a different field.
Yeah, sure. So let's kind of talk about some of the positives of delay, which I think we just hinted at a little bit. What are you typically buying with latency? And I think an area that you guys probably know pretty well, one would be scalability, and then the other would be resiliency. So what are your perspectives on that?
Exactly. That's why HLS has that 3 second, 3 segment, 3 second chunk built into it is for that scalability. Without that, you can drop HLS down to 3 chunks of 1 second. So you've gotten 3 seconds. But your stream has no resiliency. Anything happens, that thing will drop out, and you have to wait for it to reload. And drop out again, and reload. So So no one wants that. It's about a viewing experience. So yeah, 30 seconds is a dirty word. It's, but you start explaining to people, okay, you have two options. It can be worse, it can be a minute delay, or you can have a stream that crops out every 10 seconds. Which would you prefer? Are you happy with 30 seconds, or are you happy with a good solid stream? You can guarantee delivery, or do you want to take a chance of that stream dropping out like crazy? And that's where you got to look at, is you don't have that feature built in once you go low latency. I mean, RTSP has been used forever. RTSP has two options. Low latency, where you have no forward error correction. You use the forward error correction, you're adding buffer to it. So you're adding delay. And some broadcasters still use RTSP and other formats out there. It all depends what you do. Obviously, HLS is a new one. We'll see what's going on with the new codecs coming out with AV1, ATBC, and a few others. I mean, they're still working on the framework and the delivery. But again, they're probably going to go dash for delivery. So again, that spec is similar to HLS, but slightly different enough. It's more heavier on the encode side and easier on the decode, so the latency should be a little less.
And I would say because as we were developing our product, we did experiment with different packet sizes. And what we found are different chunk sizes. And another advantage that we have is the versatility with the devices we can deliver to. In other words, if we're using industry standards, I can say that, hey, I've got my stream, you can pull it up in your web browser, it's going to play fine. I don't need any special plugins, and I know it's going to perform because I'm doing what Apple wants us to do.
Yeah.
And so, therefore, it doesn't matter what device you come in on, I've got a universal experience. As soon as we started experimenting, it was funny because we tried lowering the size of the chunks, and what we found was we could lower the latency, and our initial tests were like, this is great. But then once we started testing across devices, sometimes it wasn't loading up. One device would crap out, another one would play fine. So it's that predictability, and it's part of when I get into the latency discussion with clients. Hey, you want to reach the widest audience possible without needing them to install something, without needing them to jump through hoops, without worrying that, hey, I hope a person doesn't come in on a certain version of Android that for whatever reason doesn't handle the smaller chunk size, and then it dies out on them. It's about being able to reach, and I feel like that accepting the industry standards for latency go a long way towards being able to reach the widest audience possible.
Also, the thing about it is, let me ask a quick question. How did you stream horse racing? You got one there. How many do auctions, cattle auctions, anything? Anybody stream those? Anybody doing government drones and things like that? I mean, those are the guys who really need it. One person that doesn't work.
And that's a big part of the conversation is that there's business models that that the primary requirement is ultra low latency.
Yeah, exactly.
Right? And a bet has to happen, a transaction has to happen. These things have to happen. And so the question to the industry is how are we going to address this in the absence of Flash to get back to reliable video that can be delivered in a time frame that I actually need it. And I can't make the decision to go to 10 seconds. I
exactly.
have that option.
Well, like,
so
what's his name? Oliver. So they actually have a low latency. They actually, and also, I get the name of the guys out. Phoenix is out here.
Yep.
So they all have proprietary formats, low latency, but they are under a second. And again, you can also help lower your latency by using a VPN. But you don't want a VPN via all your videos. That causes other issues. And
that's the challenge with where you talk about the proprietary solutions, and I know Oliver would be able to talk at that at great length. I don't want to say anything negative about the proprietary technologies. One thing that we're doing is we recognize, as I mentioned, the idea that delivering to an audience is different than the interactions between 2 or 3 speakers on webcam or on encoded video. Those speakers, with my technology, we need to have that real time so we can have a live conversation. So we're using WebRTC for the presenter side of things. And then we're using adaptive bitrate delivery for the audience side of things. I would love to, I've had clients go, hey, your presenters don't have any sort of latency or minimal latency. Why can't we give that to the entire audience? And I'm going, the technology's not there. Our technology today can't scale to deliver WebRTC streaming to 5,000 people, and I don't have a CDN that I can partner with. It's not like Akamai's doing, saying, hey, we'll do WebRTC for you guys.
Right.
We're still a little bit behind on that, but I feel like that's where, in my mind, that's where this is heading when it comes to that ultra low latency and that being able to do the back and forth as well, which is part of what we're doing on our end.
So we just started to cover this, I think a little bit talking about the technology breakdown. We usually talk about streaming in a sort of first mile, middle mile, delivery mile, or last mile model. Where is most of the latency today, or maybe another way to ask it is, where do you see improvement in latency coming? Is the first mile a big contributor? Is it evenly spread? Is it always the last mile with HLS where the bulk of your delay is?
Well, I'll say the most improvement will come on the ingest side, or from the first mile. I mean, like when coders like yourselves, I went out there and give me a fast stream. Now, again, the repackaging isn't very CPU intensive. There's not a whole lot of time to transcode and repackage. It's a few milliseconds in most cases, probably about 45 milliseconds. Again, it's the codecs delivery right now, and the last mile is where all the hurdles at. Again, there are codecs out there that can do that. There are tricks using VPNs and tunnels to reduce the number of pops. But again, then you're taking off CDNs. Once you want 100,000 people to 1 million people, do you really want low latency with the cause that you can probably set it to low, but you're going to lose some reliability. And that's where you got to look at, So like drones, yes. Can you stream using drones? Now, there's two things. Not the pilot, but to view the video, it makes sense. It's a pilot, we need to have real-time fast interaction. So also like some of the auctions and like car auctions. Yes, the bidding stuff has to be real-time. So you can actually have people go into a stream, they put a bid, they actually have a peer-to-peer fast stream. But the actual show itself is actually be from massive scale, which would be a high delay to it.
That's a good point.
It's like calling a radio talk show, where you call in and you hear a delay, you turn the radio off because you hear a delay. Same thing for that, you get around, you can cheat the system.
That's a great point. I think that's where this latency conversation ends up going, even as the technology changes. And even when my pipe dream scenario of having the CDN that will do large-scale WebRTC delivery, I know when that becomes a reality, there will be a cost associated to that, and the adaptive bitrate will be the cheaper approach to go. So then I think the discussion shifts into balancing the needs of the business need against the cost and the expense and the complexity of doing something ultra low latency. Just like you said, splitting out the different use cases, or like I mentioned with splitting it out for live conversation versus just straight viewer sort of conversation. And designing the interactive experiences around that so that if you are watching an auction and decide to place a bid, that you can switch into peer mode. But I think that that's the direction that all of this is really headed.
So Scott, you mentioned perceived delay in the beginning. The audience at home has no idea that it took 40 seconds or 30 seconds for that to get there. When at IBM have you found you do have to talk to the audience about delay? I mean, is it in your marketing literature anywhere? Is it in your support base?
People always ask on the phone, so what is your delay? I need a low latency. And the first question is, okay, what are you showing? They tell me, like, you don't need low latency. But the big thing is they hear that number and it scares them. It's not a minute, it's 30 seconds or 15, whatever the use case is. And I have to explain, okay, are all your people going to be watching in the same room, the monitor and the speaker? No, they'll ever be remote. They'll never perceive it. And because you literally have to hear the audio from the room, see the person speaking, then also they'll watch your 30-second delay on your laptop. I mean, if you guys are watching the stream right now, you'll see the delay. It's
we're in the pretty tough category that we do sports. We do youth sports and we do high school sports. And that's probably the toughest category. That's why I'm here, trying to find answers. We've taken away the perceived on site. I've taken it away from them because they're looking, at the site, the website that we're streaming to, and it's just freaking them out. It's freaking out all the ADs, it's freaking out all the producers out there. I'm like, do not pay attention to that because the audience is not, we are doing the production. So you can't look at doing the production and look at that. Like, oh my God, where we go? I said, they're going to see it when they see it. Okay, and we just got to pretend, just do your show.
Here's a great thing. So there's a minor league ball club up in Lehigh Valley, up in Pennsylvania. So they actually are affiliate of the Phillies. Now they want the same thing, but they want to make sure they fill up their stadium. So everything in the stadium is second screen. So you have to watch the game. But if you go get a beer and go to the bathroom, you can watch different views. You know, the kind of enhancements. But their home audience only sees one view. They see the game view, and they separate the two. And that kind of thing is because they don't want the stream on there to take away, and that you're at the game. They want you to watch the game. But they'll give you a third base view. They'll give you different views that you have. So try to enhance the experience. But then your normal home audience gets the production view you want to give, like traditional.
I mean, that's the best way to do it.
Yeah.
You're gonna freak everybody else out.
Right.
Trying to satisfy both.
Exactly.
Both cases.
Yeah.
There's no way around.
And it's challenging to explain to somebody who's there on site that the rest of the audience isn't here on site. They're none the wiser about it. They're not going to.
But even on site, okay, they're connected with the cellular network. You know, it's like going into a Starbucks. Your internet's not gonna be great there. If you were in a stadium, you have 5,000 people in there, all connected to the Wi-Fi. I mean, that's why I love the LiveU guys. They actually have some really cool ways of getting the cellular bonding out and not be affected by the local audiences there. So that's kind of a cool thing is that aspect. So again, they can use the same network, but it's saying, what if you're not using that? You're using a standard cellular network out there. Now people are viewing on the same network. More people on, slower everything gets, because you have less bandwidth to work with.
The challenge that I've run into is with the interactive elements can sometimes show the strings to the remote audience.
Yeah.
So a couple examples. One was, this happened a couple of years ago, where if the HLS ends up being 15 to 30 seconds delay, and then the MPEG dash is 6 to 8, one of our common applications is doing streaming of like CEO town halls. And the CEO, I won't say the name of the organization, but said, they had an open chat, smaller company, and he said, first person to respond to this question in the chat gets $200 gift card. And took a few beats for him to see. Somebody responded, oh, okay, Joe Smith gets it. Well, realize that the people who are watching remote see Joe Smith respond. They're like, what did Joe Smith talking about? And then they hear it and they're like, wait, this guy had a 20-second head start. And he had a lot of really upset employees. Another example of it was of just that sort of thing was with interactive polling. Push a poll out to the audience. Well, recognize that in an organization where there's a lot of people who are coming in on like IE11 where I'm not able to send them MPEG dash, they're 15, 20, 30 seconds behind. I'm a presenter. I push out a poll. I'm already in a high-stress environment because I'm presenting. And now I see nobody's responding. And it goes on for 10 or 15 seconds. And those 10 or 15 seconds feel like a minute or two. And I'm like, well, you guys don't, and the presenter said something negative to the audience. Clearly, you guys aren't interested in this. Move on to the next thing in a huff. And in reality, 35% of the audience had responded to it already, and the rest were engaged with doing it. Those are cases where I have to explain to my clients that, hey, you've got to be mindful of this, and you've got to author the content around it. You've got to know, I'm going to push out a polling question, I'm going to let it sit there, and I'm going to come back to it. We'll look at the results in a little bit. And I can't do this, hey, first person to respond gets a $250 gift card, because that's not going to work. So on my end, there's an education piece, but it's challenging because I almost feel like, quite honestly, I have to tell the story two different ways. When we're explaining to somebody how the technology works, we downplay the latency, and what I want to do is I want to prove to somebody, look, I can give you a great interactive experience, regardless of what the latency is. But then when we get to the point where we're dealing with the presenter, it's like, you got to be mindful of this latency. You really want to be thinking about this so you don't freak people out. So it's kind of two different conversations depending upon the stage of the project.
Yeah, we do the same thing. We actually, when we have we do a town hall, different groups out there, like even IBM town halls, we train the people before they go ahead. Like, if you ask a question, don't automatically go to poll, then just be ready to answer. Keep your topic going, keep your session going. When you see a few questions come in or a few things come in, then you answer the question. Don't be waiting to read the first question come in. Keep your conversation going, keep your thought going. And they start thinking about this, like, yeah, that makes sense. I have a conversation going, I can ask a question, you keep going, then you come back. And a little bit of training, you can help get away some of the fears.
Yeah, we had to do the same thing with our announcers.
Yeah.
With the sports announcers, with replays and stuff like that, we had to get some sort of training for them so they can understand, you know, what the audience is seeing. So
Right.
there's a way you can do it, you know, so
and like
when they see the replay, you know, they're seeing the replay 15 seconds later,
Yeah.
you know, so.
Well, like I explained to people, think about it. If you ever called in a radio show, same thing. You have to turn off your stereo because of the delay. You know, same thing is they understand that conversation and they go from there.
Sorry to interrupt you guys. We got a
Oh.
late addition here. Oliver Leetz from nanocosmos. He's joining us today. We've been really dive into the low latency options.
I had a question regarding actually the last lecture that we were in, the unified
Yeah.
communication. We have an added complexity, and we've experienced almost exactly that without the giveaway option. But very recently, we've done a lot of town hall meetings, and we've integrated unified communication and collaboration, i.e. WebEx, Codex, et cetera. So we had an added element of the polling and the questions within the WebEx meeting, the people in the room live, and the people seeing it on streaming that could, you know, with the delay, latency, 30 or so seconds. And we got customer feedback from that because there were also email submissions that were watching the streams. And then we also had fallback, yet one more. We had a fallback with the federal government. We still are supplying the RTMP flash streams, which were very, very low latency. I mean, it was a couple seconds. So we had this disparity of 4 different time frames, basically. And that was something new for us. Because we hadn't thought about that, and HLS is proliferating a lot more recently. So,
And, I mean, people love to give a lot of, RTMP, a lot of crap. But the truth is, I mean, there are a lot of companies out there. Almost every company out there do different ingest. Everybody, flash is dead, kill flash, kill. But again, if you want low latency, RTMP can help you get there. I mean, it's not the ultra low latency, like 1 second or less, but 3 seconds, very possible.
Well, and for applications like the ones, the town halls, 4 years ago, 5 years ago, everything we were doing was flash-based, and we never had to think about it because it was, if it's deviating by 3, 4, 5 seconds, nobody's really getting upset about it. Nobody's noticing it. And now your application is interesting because we've run into similar things where, we're blending together. We've got multiple presenters coming in via Skype, and we're blending together Skype with some video conferencing as well as stuff coming in on our technology. And that, I call it time traveling, like having to negotiate the differences between those, especially when there's multiple technologies on the delivery side, is tough. So Godspeed.
thank you.
So we're going to get to audience questions in a second, but let's give Oliver a chance to introduce himself and talk a little bit about latency on nanocosmos.
Yeah, thank you very much. So I'm sorry I somehow missed the schedule, but whatever. So I'm Oliver Lietz, the CEO and founder of nanocosmos from Berlin, Germany. We are working on getting ultra-low latency live streaming solved by providing an end-to-end solution, which is called NanoStream Cloud. And we very much focus on the delivery side, which is the greatest challenge, obviously, to achieve low latency HLS things type of solutions, which we solve by our H5 Live player, which is a unique development, picking up existing standards like HLS, WebSockets, MP4, but bringing the latency down to 1 second. So our approach is to enable low latency live streaming end-to-end within 1 second worldwide. And that's all browser-based. So to have complete control over all elements, I'm sure we discussed that already, based on the encoder, the first mile, the middle mile, but also, of course, the last mile, which is very important for browser-based scenarios to keep the latency under control for these scenarios. And we kind of work based on a kind of edge computing approach. I just learned that phrase, so I didn't know it before, that we control the edge player communication very closely to keep latency under control. And that's why we needed to create our own CDN based on that. So existing CDNs already lose the latency, as you know, so the HLS chunks cannot get back. And so we created this solution which connects the player part from an HTML5 point of view to the edge part directly to keep that under control. There is also a solution on the encoder part, maybe some words on that. That's based on WebRTC. And that's not to be mixed up with WebRTC peer-to-peer approaches and delivery. On the delivery side, we only do that based on the ingest side for live encoding as a replacement to live encoding solutions like Flash Media Live Encoder, Wirecast, whatever. You can still use that, and I would agree that RTMP is still a valid solution for that, so why not? Facebook is doing that, YouTube is doing that, everyone is doing that. And so you can use that, but you can then pick up the existing live stream, but you can also replace that with a WebRTC ingest solution and work in the browser. So we are using that to reduce complexity on the player side only for the ingest, and for the player side we developed something which picks up on lightweight standards.
Well, like you mentioned, you actually control from ingest to the delivery. So you can actually transcode, deliver, and package, and you own it end to end.
Exactly.
So that makes sense. Where single CDN versus running through Akamai. No knocking Akamai, but Akamai is designed for massive scale, million viewers, multi-million viewers. They have latency built into their system for their own QoS. For your own system, you can streamline it and make it faster, and you can customize it versus, hey, Akamai customizes it for you. No. Exactly. $100 million, no.
So let's jump over to audience questions, I think, if we have any. Go ahead.
Yeah, just a quick question. The relationship between geographics and, latency. Because, when we do around like when we do sports show, and we're finding that, it's 15 seconds ahead and 20 seconds somewhere else. And is there any way that you can get some sort of consistency or do something to get some sort of consistency? I'll live with 15 seconds. If I can have 15 seconds everywhere I go.
Right.
But that's not the case right now. We're usually stretching from 15 seconds to as much as 25.
I'll jump in on that answer. As a first mile encoder, we can definitely give you a fixed delay to the cloud, right? So as long as we can then predict the rest of the delay from the cloud through any one of these systems that you're going on, something like the LiveU encoder would give you a fixed delay from where you are to give you more control over that. Since we're using our own protocol from the encoder up to the cloud, and that protocol builds in delay as a key feature that we have exact control over, then we can tell you very precisely.
Well, we don't seem to have a problem with the first mile. It's the last mile because we use like TVU, as a bonder, and they're pretty solid. And we really haven't had no problem. I mean,
but you're finding a difference in delay geographically, even though you're using something like a TVU to get out.
We had an issue pops up. So I was working with a TV station in Austin, and for some reason, think about it, Austin is a hotbed of technology. Houston. So Austin stream was great, but for some reason, Houston, no matter what, they were 30 seconds longer than Austin. And you think about it, well, it's the same pops, roughly. Like, what's going on? It was a localized piece. They were doing throttling. They didn't have enough bandwidth to go through, so they were throttling everybody and delaying everybody. They didn't have enough fiber rings, nothing, enough connectivity there for that massive city. So that's one of the issues. You go to some areas, they just don't have the infrastructure built in. So now, in theory, you could do, I'm not recommending this, you could put a VPN around the stream. What you'll do then, because actually like Zixi and DVO all have things called private line emulation. What it does is you can actually hit less pops. So I used to work for DVO, my previous company. So we were actually able to stream from Cameroon to Atlanta 5 seconds. And by itself, straight from the internet, it's gonna be 45 seconds or a minute. So, yeah, but again, you don't have the scale. It's the cause and effect. Do you have scale? I mean, or do you want, the aspect in there? I mean, the different aspects. I mean,
that approach you described, were you seeing any sort of, taking any sort of hit on resiliency, or was it just scale?
It's scale on that one. On the private emulation, because again, you literally can't lose packets, so your stream can't die out. Because the packets can't go anywhere. It's like inside of a fire hose. Nothing can leave. Water's going to go out no matter what, and it's assembled correctly. But again, I need 200,000 viewers. No one's going to do that. I mean, there's a few CDNs I think you can have with your idea. It's kind of the same idea. So like, are you using like a pipeline emulation, or are you just using your own packaging, going through and delivering?
Yeah, we're doing that, but it's we're trying to make that a bit intelligent to have a close connection, and that's why what you often see that if the client doesn't know what is going on, so you wonder where the latency is coming from.
Yeah.
So that's why we created that close connection path between the browser and the edges, so you have complete control over that and get more insight on what is happening.
So that means like these guys are actually taking that early option and making it to scale. And that hasn't been done before. And this is why it's a newer aspect. People who need no latency or reduce latency and so on. And now you have ways of doing it because he's offering obviously scale.
Any other questions out there?
Oliver, can you comment on how, what scale you can achieve and what the global geo of your CDN reaches?
Yeah, so it's a global scale. We have primary locations in North America and Europe, but also increasingly in Asia. We also have setups in Australia. So it's basically worldwide. And it can scale up to thousands, maybe 100,000 viewers. So that's something which is possible based on our system.
Per stream?
Yeah.
100,000 per stream, okay.
Go ahead.
I think, Scott, you mentioned that you think that MPEG Dash is more superior to HLS.
No, I didn't say that. Each one has their own stuff. I mean, Dash is it's lighter, it's heavier on the encode side, lighter on the decode. It's kind of like they're kind of modeling a little bit like, remember the old VC1 days versus MPEG-2, ABC? It was very CPU intensive for VC1, but it played back faster than H.264 did because it was lighter on the encode side. It's actually almost 50-50 versus VC1 was 75-25. So, I mean, there's a lot of things going to Dash. There's also different developments of Dash. I mean, the framework's there, but people are delivering slightly differently too.
Yep.
Yeah, but I would agree. The technology is not the answer. So it's the whole case.
Yeah.
All components play a role in that, and so it's.
Yeah, because I mean, like obviously I can't do Dash to an iPhone. It all depends what my audience is, but like you said, if you've been a corporation, he has the guys who can view real low, and they have the Dash option. Well, if you have a better experience on Dash, you tell all your guys, your IT staff, only have this viewable.
Right, and that was part as we shifted away from the flash-based delivery. It was like I mentioned when we were talking about flash, we were talking 3 to 4, 5 seconds of latency. It wasn't a consideration. Today, if I've got the entire viewing audience coming in on a Dash stream coming through Firefox or Chrome, I don't want to say it's not a discussion, but it's minimal. It's 6 to 8 seconds. That's not anything that's going to that anybody's necessarily going to freak out like they would with 15 to 30 seconds. So we've chosen to favor MPEG Dash where possible. There are the trade-offs like you had outlined on the infrastructure side, but just because we know latency has been such a big topic and such a big concern, we want to minimize that wherever we possibly can.
Like an proprietary stream is a version of Dash. So we actually deliver HLS, but for legacy Ustream. So we've always done an MP4, chunked up MP4 delivery, basically using FLV, things like that. So it's very similar to MPEG Dash, but we also have an option for HLS. Now, luckily, we're actually pretty in sync. Our stuff meets right in the same spec. So latency for one meets latency for the other.
You lucked out.
Someday?
What?
Will one of these two streaming one day?
I personally feel that Dash one day will be prime, because even Microsoft is attending the Dash meetings finally, and they're finally contributing. With Microsoft, Apple.
Yes, Apple.
Sorry, I'm full with Microsoft. Microsoft doesn't care. They want to go Dash anyways. But the HLS guys, I mean, they're pushing back, but they're starting to realize, Dash is getting traction. They're looking at, well, no one's really looking at HEVC deliver HLS. They're looking at it for Dash. They're looking at it in AV1 for Dash. So that's kind of the route that, people, even Apple's looking, it's like, well, just keep HLS now, but we better start investing and looking into this and see if we need to build our own version of HLS, for a newer version, future-proof, or if we just jump on board and we go after this new codec. And obviously, it will become a standard. I think it already is a standard, right? Is it a SIPI standard?
It is a standard,
Yeah, it is a SIPI standard. So HLS is. It's kind of like, the weird way.
The weird Apple way.
Yeah.
But here's the question: would you gamble on that? Would you gamble to say that MPEG Dash will 3 years from now will be at a different landscape where these HLS considerations go away? Because I sure would.
Given the history, I would, because other than being working with Microsoft in the early days, I mean, how many use VC1 anymore? Yeah, I mean, if you look at H.260, 264, beat out, it became a community standard that more groups bid on. VC1 was great, except until Blu-ray, decided, nah, we're not gonna use you, then it died. It was almost like overnight, it was great. ASI264 won. So again, what is HEVC and AV1 gonna use? That's really gonna be coming to the future, or is there a new codec that's gonna come out in the next 2 years, and they'll piggyback. How many use MOV? I still do, that's still around. So there's different things around there, so is HLS gonna go away in the next few years? No. It's like, it's like Flash. Flash is a long, agonizing death. It'll probably take another 5 years before it dies. Maybe 10 years.
Any other questions out there? Back here?
The delays that you are quoting here for MPEG-dash and HLS, are those delays including a CDN or they're excluding a CDN?
Numbers I've been talking about include the
Yeah.
CDN. So we're talking the end-to-end or glass-to-glass delivery.
Yeah.
Yep.
I think we got time for one more. Go ahead.
How do you balance the need for a buffer in a playhead buffer in order for smooth playback experience versus low latency? The smaller the buffer, the lower the latency.
Yeah.
So we hit on that a little bit with resiliency, but yeah, Oliver wasn't here.
Yeah,
So
that's a good question, of course,
question.
and there's always a kind of trade-off, but that's why it's more important to have complete control over the connection between the edges and the players. So that can be dynamically controlled in a more intelligent way than just having a dumb consuming player which tries to pull some chunks and then it doesn't know where the buffer level on the server is. So with that approach, to keep latency really down, you need to have that in an intelligent way to be connected and to have these the client-server connection valid in a special solution, like we do with the H5 player.
And for us, we don't allow you to adjust the trunks. We follow the default standard because our whole thing is quality of experience, quality and overall massive delivery. So we want to make sure you always get packets there. So we can't allow somebody to reduce their packets because if something does happen, it could, in theory, even Akamai knows is an outage or a small outage can cause a major outage. So you never want to have somebody cause a ripple down the line.
Yeah. And we're in the same boat where it's platform-wide,
Yeah.
we just adhere to the standards when it comes to the chunk size.
Yeah.
We've got the ability to tune it inside of the platform, but that's something that, let's
Yeah.
keep that inside of the room here, because I never tell my clients about.
Okay. Thank you, everybody. Thank you to the panel for coming.